Hi. So I'm in this talk. I'll be speaking about the Wolfram Data Science Platform and doing data science in the cloud with it. I will very quickly place it in the context of the other cloud platforms that we have developed, are developing, and are coming out soon. And I'll give you a little bit of motivation for doing data science in the cloud in the first place, and the kind of problems that this is expected to solve, and why you should care about having a cloud-based data science platform in the first place. After that, I'll give you a demonstration of the workflow using the data science platform, using a couple different data sources. Okay, so we started putting out these cloud platforms starting earlier this summer when the Wolfram Programming Cloud came out. The emphasis in this particular platform is on programming, on developing applications and deploying them, and on helping small teams and startups collaborate on them. Very soon we'll be coming out with Mathematica Online, where the emphasis is on extending the desktop Mathematica experience into the cloud. If you saw the keynote yesterday, Stephen Wolfram also mentioned the Wolfram Discovery Platform for research and development, and he mentioned the programming lab. So the data science platform is very much in this family of stuff. The emphasis in it is on this sort of canonical data science import, analyze, publish workflow. And you might reasonably ask, why would you want to do this in the cloud? Maybe I'm perfectly happy doing my data science on the desktop. I think part of the answer is collaboration, and to some extent that's true of any sort of cloud application. But more of it has to do with accessibility and reach. And let me explain what I mean by way of analogy with computation. So funny things happen. We're finding that funny things happen when you cloudify notions, even long-standing notions, from a desktop paradigm. So one notion is the notion of the function. So you may have seen this yesterday, the notion of an API function. An API function is a cloud version of a normal function. This particular one expects a country as input, and it's going to output a map of that country as an image. And if I want to, I can run this on the desktop. So there's no cloud involved here. I'm getting a map of a country from that function. But interesting things start to happen when I deploy this to the cloud. I get a URL back, and I can use this URL to invoke the code that's in that API function. So here I've asked my browser to go out to the cloud, make a request in the Wolfram Cloud, and it serves back this image to me. So my browser doesn't know or care what the technology stack up there was. It just got this image back. So in this case, it was a browser. It could have been an app on my phone. It could be anything that makes an HTTP request. So 10 years ago, 1 year ago, a couple of months ago, if I had given you a piece of Wolfram language code and said, could you please execute this for me, your answer would have been, no, I don't have Mathematica. But you don't have that excuse anymore. I don't have that excuse because I can publish stuff as an API function, and you don't have that excuse because you have a web browser and you can make HTTP requests. So, software futurologists have been saying for a long time that the cloud is going to make platforms irrelevant. It's going to place everybody on a level playing field, and that's sort of happening for Wolfram language stuff. So that's what happens for computation. So my claim is that when this happens for other things, it has benefits for data science. And one of the things that changes quite a bit is, or one of the things that it has benefits for is for computable documents. So if you've never, if you have limited experience or no experience playing with the Wolfram system, the principal interface to it is manipulating these computable documents. So these are notebooks that can contain data, formatted text, typeset mathematics, code, interactive elements. Here you're looking at a chapter from a calculus textbook. Here you're looking at a medley of some entries in the Wolfram demonstrations project. Here you're looking at a report compiled for the state of Texas on the economics of buying certain kinds of disaster insurance, and so on. So in my opinion, these computable documents have been one of the best arguments for doing data science with Wolfram stuff in the first place, but they've had the disadvantage that they are only as effective as the decision maker's ability to consume the format. So it's become a distressingly common story that you talk to somebody who has done this wonderful analysis, worked up this wonderful analysis in a notebook, and you say, well, what happened when you showed that to your bosses? And he says, well, they don't have Mathematica and they couldn't open it. And you say, well, couldn't they download the free CDF player? And he says, well, IT didn't let us do that. And you say, oh, okay. So now the excuse for this is disappearing too, because we've codified the idea of having computable documents. And so these just open in a web browser now. The destination platform is becoming irrelevant. And we're finding that this is true in smaller ways for all kinds of things as we cloudify them. So concepts like, so the second most common story I think is, that's a great report, can I get that every week? Now on the desktop, that's a hard problem. In the cloud, it's actually pretty easy. And the reason it's pretty easy is because we've had this notion of scheduled tasks, which has been sitting around in Mathematica since version 8. When you cloudify that idea, you get something like cron, right? You can run things on a server on a regular schedule. So the idea of distributing a report suddenly becomes very easy and running it automatically. Okay. So this is my claim about why you should care about having a cloud data science solution. Okay, so let me show you what the platform actually looks like and do a couple things with it. So I'm going to take the URL of a data source, and I'm going to flip over to my web browser and show you the homepage of the data science platform itself. Okay, so this is the homepage of it. These 4 big red buttons across the top are commonly used channels for getting data into the system in the first place. So whether from connecting to an external data source, importing it from a URL, choosing a data file that you already have in the cloud, or uploading something from wherever you are. So if I were going to upload something, I would do something like this. In this case, I'm going to import some data from a URL. So what is this data source? This is an online spreadsheet that I keep of utilities usage at my house. Okay. So what's happening right now? So the platform took my data source, and it's preparing a notebook for me, a computable document, which is seeded with some code to help me start doing an analysis. Now, this is a special kind of notebook called a template notebook. You can recognize it by these buttons across the top. There's nothing scary or special about this. So if I'm in the desktop, these exist too. Okay, and what these buttons do is they allow you to create variables called slots in your template, which are filled in with whatever you want to fill them in with when you generate a document from this template. So for example, I can give this slot the default value of 42, and then when I generate a document from this template, that slot will be filled in with that value. Okay, so that's the fundamental operation behind these. That's the fundamental idea behind these templates, and they exist in the cloud. They've been cloudified too. So what I'm going to do with this notebook is start working up an analysis, and when I'm happy with it, when it's to the point where it can produce a document that I want someone else to look at, that's a reasonable thing to give to someone else, including myself, I'm going to deploy it in the same way that I deployed that API function and schedule it to generate those documents from this template that I'm working on now. Okay, so how do I start? Well, I can import the data, and I'm not only going to import the data, I'm going to semantically import the data. So semantic import is this new function that you may have seen yesterday in the keynote. It not only does the mechanics all the mechanics that import used to do of getting the file into memory for you, but it also tries to recognize things in such a way that they become interesting and useful to human beings. So for example, in this data set, my first column has the date. The dates appear just as strings in the original data set, but here they've been recognized as entities, and will behave intelligently when I do things like try to plot using that column. Similarly, columns that had monetary values in them, US dollar quantities, are recognized as such and are given units. Okay, so this thing that I got back, all right, is called a data set, and it has its own sort of rich query language associated with it, and that's sort of its own talk. But using this, using this data set, you can slice and dice data and start doing visualizations with it. So you can imagine sort of fast forwarding 2 hours when I've had a chance to work up some visualizations based on this data. I might wind up with a template that looks like this. Okay, so in this version of the template, which is fast forwarded a couple hours, I've done some cleanup. I've excluded a line from the original set that was duplicated. And I've started doing visualizations like this, time series plots of my electricity and gas usage, and then other more complicated stuff, including forecasting and doing things like time series model fit, so I can figure out what my utilities bill is going to be next month. Okay. So when I'm happy with this, I'm going to deploy this as an automated report. This is the same kind of deployment that I did of that API function from the desktop. And in this UI, there are all kinds of little dials and knobs that I can twiddle. I can choose the output format of the that I want the report to be to have. I can specify recipients for it. I can specify attachment formats for those recipients. I can set a schedule. Let's set this to run at the end of the month, since that's when I tend to get my bill. And I can create this thing, and it's going to show up in my list of reports here. Now I don't have to wait for the end of the month. I can ask for it to run right now. When I do that, the cloud is spinning up the necessary machinery to apply this template, and then archive the generated document and mail it to whoever it needs to be mailed to, make it available to whoever asked for it. While we're waiting for that notification, I can show you the results of a previous run. Okay, so this is the result of applying the template that we were just looking at. You can see my gas usage peaking in the winter, my electricity usage peaking in the summers. You can see distributions of my electricity and gas usage. You can see the same distributions broken out by season, summer and winter. You can see a little bit of forecasting data. Here's my combined electricity and gas usage. Here's the combined electricity and gas bill, along with a 12-month forecast according to the results of a time series model fit, which creates, I think, a SARIMA model of my utilities usage. So I'm on the hook for something like this, $116 this month. Okay, so you can you can imagine taking this further in all kinds of ways. The next thing I would probably do is compare the last month's forecast with this month's actual bill and see how my models are actually doing. But at this point, you get a sense of what the end-to-end workflow is. You start with a blank screen, not having any data in the system. You point it at some data, you get it in there. You do the semantic import. You fiddle around with your data until you get something you like, and then you deploy this thing which can be sent to a decision maker, including yourself. Yeah, question? Encrypted? Beg your pardon? You can. We don't have any encryption per se on the results, but you can control. There's very fine-grained permissions control on the output. So you don't. Of course, you don't necessarily want all these URLs to be wide open. So if you want to share them with only specific users, you can. Let me show you another example, which showcases semantic import a bit more. So this is a cute data set. This is an inventory of trees in Champaign, Illinois, where I live. And this is done by the city. So what do you get in this data set? Well, here are the columns. You get a tree species and a common name and a couple of figures about the size and shape of the tree, and then you get a location and latitude and longitude. So when you semantically import this thing, the species are actually recognized as plants. That's one of the things that semantic import can recognize. And plants have almost 150 properties that can be queried and are available to you in your analysis. For example, you can, if you're curious, you can confirm that the foliage color of a red maple is in fact green. Okay. You may also notice that the latitudes and longitudes have been identified as geopositions, and this makes them very handy for mapping, as we'll see in the template. So you can imagine doing the same thing that we just did with the utilities data and working up a template based on this data. Here is one. Here's a semantic import of that data set. This template is going to do some very basic data science-y stuff, like compiling a top 5 list of the most common trees in the set. It's going to build a map of where the trees actually are, and then it's going to do some filtering on particular species. So we can deploy this using the exact same mechanism that I was just showing you, going through this UI, giving it a name, specifying recipients and formats and so on. Let me show you the results of a previous run. Okay, so here's the results of applying that template. Red maples are the most common tree, and almost 1 in 8 trees in the city is a red maple. Here's the list with thumbnails. These thumbnails came out of are one of the entity properties, so we got them for free. We didn't have to do any work. And we can make a map too. So here's a pushpin map of a sample of the trees in the city colored by species. I had no idea there were so many distinct species of tree in the town, so this is a little bit overwhelming. Here's a map with the results filtered to ash trees only. Now, I was curious about this because in Illinois and in many parts of the US, ash trees are being eaten by these guys, emerald ash borers. This data set didn't contain any information on sick trees, so I simulated some. Okay, so I simulated an outbreak of ash borer disease, and I colored the sick trees red. Okay, so here's the map of a simulated ash borer outbreak on the west side of town here, about 2 miles from Wolfram Research Headquarters. So you can imagine if you work for the Parks Department in the city, this would be a useful thing to have in your inbox every Monday morning to see what's happening to the spread. And I hope this sort of reinforces this conceptually very simple workflow of getting in data, making a template, and then producing a document. Okay. Okay, and we have lots more examples of these kinds of reports and producing them. And if you're interested in particular verticals or particular aspects of producing them and what they can do, things like encryption, I encourage you to speak to me, and I can get into more detail about them. One of the things that we think very hard about is the language design. This is a primary consideration for us. So if there is something in the GUI that you cannot do with the language, it usually means that we've made a mistake. And as your experience with these systems grows, you tend to move from clicking your way through them to scripting your way through them. So just to give you a sense of what that looks like, here's an example of a report that is scripted and deployed completely from the desktop, so I don't have to touch the cloud at all to get to a deployed thing that is running automatically up in the cloud. So what is this one doing? This is going to fill in a template that looks like this. So this is I'll magnify that a bit. So this is a stock report. The input of this thing is going to be a list of financial instruments, and the output is going to be some statistics about them presented in little interactive manipulates. Okay. So that's a template I'm going to use. This particular report is interested in locating the top 5 members of the trucking sector by yesterday's trading volume, and then compiling a stock report on that. Okay, so this gives you a sense of the code investment involved in doing that kind of logic. That's all encapsulated here. You can see this built-in financial data packlet that is doing the business of finding out what the members of the trucking sector are, and finding out what the volume was yesterday, and so on. The actual deployment of this report is done here, where we specify the template and the schedule that we want to use and a couple of options. So when I execute this thing, all of this logic in this template are being shoved up into the cloud and being deployed as one of those things that the net effect of this is exactly what it was through the UI when I pressed the big red deploy button on the website, and I can tell this thing to run. And in the meantime, I'll show you the results of a previous report using this template. Okay, so these are the top 5 stocks in the trucking industry by yesterday's trading volume, and then here are some more details about each of them. Okay, so the takeaway here is that this was done completely from the desktop. The scripting of this was done completely from the desktop. The interactive elements in the output document survive into the generated document, and they're available even in the cloud. Okay, so here I am in the cloud examining the output, and these manipulates are still operational. Okay, so this gives you a sense of how sort of fleet and how easy it is to prepare these sorts of reports. You know, if you have to maintain situational awareness about lots of different things in your job, and you quickly need a report about a kind of thing that you haven't considered before, this is sort of the speed with which you can spin these things up. Okay, I myself, I'm particularly excited about the data science platform because because of the way that it solves these accessibility problems that have historically plagued using Wolfram stuff for data science. For the most part, they're just sort of melting away, and this is going to be a good thing. And this is happening in the short. This is happening now in the short term. In the longer term, I'm excited about the ability potentially to do to elastically make computing resources available to a data science job. Now that's something that we could only really dream about on the desktop. In the cloud though, it's getting very close, and using our experience with grid computing and so on, I think that will happen in the medium term. If you have any questions about what this thing can do, we anticipate that it'll launch in a matter of months. If you have questions about what it can do, if you'd just like to tell me what your needs and requirements are, we love to gather stories and would like to talk to you. You can talk to me, here for the rest of the conference. You can feel free to send me email afterwards as well. And we also have 3 team members at the conference, Clayton, Jeremy, and Deepak, who would also be glad to be buttonholed. Thank you.